Hi, Corey Sanders here, Director of Program Management in the Microsoft Azure team. And today, I'm going to talk to you a little bit about Docker containers and Azure. I'm going to explain a little bit about what these things are, how you may want to use them, and walk through a few samples that will show you how to use them on VMs running in Azure. So first, let me start with a huge picture of the entire platform. You can see every piece, every part of the platform that we offer here. Today, the focus is really going to be the Docker containers running on virtual machines, and I'll dig into mostly conversations around that here in the bottom left with the small little red square around it, or rectangle, excuse me. So first, to start off the conversation, I really wanted to spend some time just telling you at a high level, what are these things? I'm sure you've heard about them. I'm sure you've seen press. You keep hearing this Docker thing. What are these and sort of how are they going to be used? Well, in a very simple way, these are just virtualization technology that offers isolated and independent compute components running on a single machine with resource governance. So great. What does that mean? Well, if you look at this picture of sort of what virtual machines have offered in the past, virtual machines have offered this ability to replicate in a virtualized way an isolated instance that has the VM OS, the files, and the libraries all tied to that virtual machine, with the host OS and libraries of that host shared across those multiple virtual machines. Well, containers are somewhat similar in the way that they approach this problem, but they actually can share the VM OS as well. And so they offer this isolation, this view that they're alone in the world. They have complete control when really they don't. They are sharing that virtual machine OS underneath and offer a lot higher level of density and a lot faster speed to start. And so when you really get into what this means, it means that as you build out your application, you pulled your binaries, your libraries all together into a single container, but that virtual machine underneath, that OS that you're running on, is shared across these multiple application packages or containers. This makes a very, very lightweight way to virtualize these solutions. These containers are very small. They can be moved around very quickly, and it makes it just the application pieces that you need. You don't need to carry around all the muckety-muck of that OS with you. Just take the app around. So with that shared solution, you also have a lot higher density. You can put hundreds, nay thousands of these containers on a single operating system. Versus with virtual machines, you have a little bit more limit there because each one of the guests have to be replicated. In this case, again, you're sharing, and that share of the kernel makes that efficient, a lot higher level of efficiency. It also gives you this flexibility. And this is really where we're seeing containers take off. The ability to take that same container, put it on perhaps a local dev box, and move it around to a server machine, and not really care about the underlying OS because the OS isn't with it, makes a lot higher level of flexibility and agility for developers, and then the system administrators supporting those developers when deploying the applications. And I'll talk a little bit more about that later. The last one is also incredibly important, is the speed to start. And when I walk through one of the demos, you'll see how fast these things start. Virtual machines take an OS boot. They take the time to set things up. With containers, because you're borrowing from the underlying guest OS, you don't actually need to wait. All that's happened for you, and you can just immediately run the app that you want to run in the way you want to run it. It's a very exciting time for us to be able to deploy applications in this way. So you may be saying to me, well, great, Corey, that's super interesting, but how are these different from virtual machines? Well, I'm glad you asked. One is, of course, the level of dependency. Each virtual machine carries with it the guest OS, which means changes to the guest OS carry with it, which is a positive, but the size of the guest OS also go with it, which is a notable negative. With virtual machines, each OS is independent. So you can have different OSs. A great example of this is if you're running a hypervisor, let's say Hyper-V, and you want to run a Linux machine and a Windows machine, because the guest OS goes with it, you can run both of those virtual machines on a single Hyper-V instance. However, with containers, because it's pulling from that guest OS underneath, you actually cannot run different OSs on that same host OS. You actually need to make sure that you're running the same OS between the two because it's sharing from the underlying shared operating system between them. The really nice thing is the flexibility point. As I mentioned, there's two different types of flexibility. The virtual machine has flexibility, then it's very easy to move between different hosts. You can move it around, you can move it based on maintenance, live migrate it between instances, whereas containers, because they're tied to the OS itself, they actually are stuck on that box. And so they end up being stuck on the underlying host OS and don't end up moving as flexibly as virtual machines. The level of security is a big question. Obviously, the level of security and the isolation that's offered when you have the full OS contained with your application is higher than when you're sharing an OS underneath. And so that level of isolation is important when you're considering the way you're deploying your applications. And so the next big question is, outside of the technical conversation, how are these things being used? Well, the area that I think most people are getting excited about when it comes to containers is the flexibility and speed, the agility to deploy many times on a dev box, on a server box, get things going quickly, get them started fast and torn down fast. It makes it really easy to go and get going with these applications. But once you get that application going and the development process rolling, the ability to then take that same exact solution and deploy across dev, test, and production environments, whether in cloud or on premises, is an amazingly powerful part of containers. And this is where Docker has really come in and shined as part of the overall story. Docker offers this consistent deployment technology and unified packaging format that makes it very easy to deploy across all of these different environments. It creates a simple solution to create, then test, then deploy into production using the exact same file format and same CLI runtime experience across all of them. Absolutely amazing and really powerful for customers to be able to take this next generation of application deployment and development. On top of that, because it's been so easy to be able to deploy in all of these different environments, the community around Docker has really grown at an enormously fast rate. The amount of available images that you can get at Docker Hub as just one example and be able to deploy hundreds of thousands of different solutions in a matter of moments is really mind-blowing. Across things like Redis, just an Ubuntu solution, WordPress, MySQL, Mongo, all of these options are available for very fast, easy deployment directly on your guest OS. And so you can get going with these applications with almost no lead time, and you're able to deploy, launch, and start playing with Docker in a matter of moments. And so instead of me just blabbing on about it, why don't I actually show you what this demo looks like? And so for the first demo, I'm actually going to spend some time here on my Mac, and I'm going to be doing the demo for a Linux-based machine to show you a little bit of what this looks like on Azure, running with a Mac and doing a Linux-based deployment. So first, just to get started, I've already deployed an Ubuntu machine. And so you can see here, it's called Ubuntu Doc 2, planning for the Docker test. And so what I actually have already done is I'm already connected in to this terminal. And so I've got the terminal up here, and just to show you a little bit of sort of what this looks like, you can see I'm logged in and it's Ubuntu Doc 2. And the ability to get going with just a single, very simple command and download the Docker experience in just one command. With this simple command, away I can go and be able to launch this full Docker experience with just a matter of moments. And so it will download all the latest bits and prepare my machine to be able to run Docker straight away. Now, obviously, I've gotten this going already, and so I already have a machine up and running. So let me switch over to this existing machine that I've got. And we'll just let that kind of install here in the background. And so here I've got a machine already up and running. And so just to test, let me just kind of make sure and see. Okay, it's running and I'm ready to roll. So the very first thing I'm going to do is start off, and let me just make sure that this is running correctly. So I'm going to pull a container down called Hello World. And I'm actually going to quickly just show that Docker's up and running and it's healthy. So I'll go ahead and launch that. So there's the container name. And sure enough, it pipes out this message to me. Oh, how wonderful and friendly. Hello from Docker. How delightful. So this pipes this out, and I'm now able to see that Docker's up and running and Hello World worked. And so from there, let me actually pull down an interesting container. In this case, let me actually pull down Ubuntu and get that on my local box. And so it's going to pull the latest. And so let's just go ahead and see what I've got now for my images available. Always got to use sudo here. Oops, there we go. And so here you can see I have a few images available on my box. I've got the Hello World one, which I just ran. I've got Ubuntu, which I just pulled down. And I've got a couple others, which I will show as I go through the demo. And so here you can see, let me actually go and start up a container using Ubuntu. So here I'm going to make it interactive mode. And so what I'm doing here is I'm actually spinning up just a bash command so that I can run some commands on this local box. The -I makes it interactive. I'm going to actually work with this container while it's live. And the -T actually makes the keyboard pipe out to me. And so let me just go ahead and run that. And so again, within seconds, you can see less than seconds, milliseconds, this thing is up and running, and I'm now sitting in this virtualized, this pseudo environment that's a bash experience that's running on Ubuntu. And so what I can do here, you can see I'm running here in the root. Let me just make a directory here. So make dir, let's see, Corey rules. Okay. And so here you can see I've made a directory, and there is Corey rules, and this is in my container environment. This is in the virtualized environment that this is created. And so there it sits, and I can do whatever I want to with this bash experience. I can go delete things, launch things, what have you. In this case, again, I made that that directory. Now let me exit out of here. And so now let's go into the root of this machine. And so here you can see there's bin, exe, home, boot, etc., but no Corey rules. There's Corey rules in the container, but now there's no Corey rules here. Corey does still rule, but it's just not a directory that's in my experience. The main reason for this, it was a virtualized environment. So that was completely virtual. It was separate. I'm back to my running OS, my host OS here. It's gone. And so in a matter of seconds, I've gone in, I've created a container, I've connected to the container, I've done some work. I've now left the container, I'm back to my original environment. This is the power that you can really get from Docker. Just the speed, the experience, it's all the same to be able to go through this. And so now let me actually go in and say, great, what are the containers that are running on this box? So Docker PS tells me that there's no live containers running. So let me actually list all containers, whether they're running or not. And so here you can see, great, I've got a few. Here's the bin bash container that I just spun up. You can see about a minute ago. It was called Agitated Lovelace. They pick the name for you if you don't pick a name yourself. And this was just running, and it's been exited because I exited that container. Now, what if I really like the fact that I created that Corey rule situation on that container? It's stopped now. Why don't I make a new image from this? So let's go ahead and grab the name of this container here. So we'll copy this. Great. Paste it here. So I'm going to commit that container, and I'm going to name it some new image name, Corey image. And so I'll start by doing just the sudo command with Docker, commit, get the container ID, paste that in, pick the new name, and away I go. And so you can see here, I've now got Corey image as a new container that's been, a new image, that's been created. And so now I can actually go ahead and start the same command. So start this up again and pick that specific image and again run bin bash there. And let's get that started. And here you can see, there's the directory, Corey rules. And so I was able to create that directory in a container, exit the container, create a new image from it, restart it, and there it is again. And so you can see the power of this. I could share that with a friend, make sure everybody in the world knows that Corey rules by getting that container out there as much as possible. Great, so moving from here, now if I want to go in and actually clear my screen and actually start by picking up and deploying an actual web application. So maybe I don't just want to use bash scripts, but I actually want to build an app that's going to take traffic from the network. And so what I'll do here is, again, I'll start up with Docker. and this time, of course, run. But in this case, I'm actually going to specify that I want to open up a port. And I want to open up port 80, pointing to 5000 in this container. And I've got an app, actually, that I've downloaded from Docker. And it's a very simple Python app. And this then experience to be able to run this entire app will set up this port, launch it for me. And you see, again, within seconds, this is launched and ready to go. And so let me actually go to this site that I've now opened up. And I've removed sort of the security rules on this instance so that I can go find this site. And so taking the IP address from the website, you can see here in the upper left, very small, not really a great website per se. You can see Hello World. And so this container got up and running, launched within seconds, and now I have my Python website taking traffic. And so very exciting, very powerful aspects using on top of a Linux machine, running in Azure, the ability to deploy these applications in moments. So let's get back and talk a little bit about the Windows Server container and how this plays out with the rest of the things I just showed you. And so the Windows Server container is very similar to some of the experiences and solutions that I just talked about. The application is sitting together in a container format with the binaries and some of the libraries, but with an OS that's going to be shared across multiple containers running on a single box. So the expectation is developers will build these applications, put together their components, binaries, libraries, application, etc., and be able to build them tools like Visual Studio and be then able to update them at their own cadence in their own way. They'll run on top of Windows Server. So very important, Windows Server containers will run on top of Windows Server. They will not run on top of a Linux-based OS. And likewise, Linux containers will not run on a Windows-based OS because, again, it's pulling from the underlying shared OS. And then you can deploy and manage them using Docker. And I will show you very similar experiences to what I just showed you using the Windows Server containers on a Windows machine. And of course, the same sort of resource governance and controls. You can define CPU, memory, and be able to control access to all of these as part of the launch and deployment of these containers. And so with the Windows Server containers, one of the more exciting aspects of this release and capability that we've recently added is the fact that this is a joint strategic investment working with Docker Inc. and the Docker community. The ability to take and use the exact same Docker experience in both is amazingly powerful and really exciting. The investment that we've made to make the Docker engine that sits on Windows Server containers have the same API was actually in the open source community working with the Docker community to build in their repository. And so this Windows-based solution has been built as part of that repository. Very, very exciting. Azure also supports the Docker Open Orchestration APIs, and we have federation of the Docker Hub directly in our Azure experience. And so many different places that we've had Docker integration, very, very powerful stuff. And actually, let me spend a few slides here to show it to you in action. And so like I mentioned, the Docker Hub in Azure, I will show you a demo of this later. Very powerful, large collection of these solutions. The Windows Server containers in the Docker ecosystem to make developer communities be able to span both environments. And of course, that Docker engine being available is an open source project, making it easy and very possible to add solutions and integrate it with other technologies down the road. So let me actually take a moment and show you what Windows Server containers look like. And this should hopefully look very familiar. So let me go back to that same experience that I was showing you with Ubuntu. And let me just show you how easy this is to get going on the Windows side. And so on the Windows side, I can go in and through Compute, and here you'll see Windows Server Container Preview. Well, isn't that convenient? Go in here, you can deploy, and it will set up this server machine to be able to directly use Windows Server containers on the box from the get-go. And so instead of actually doing this now, what I will do is I will actually go to one I've already created. And so here I've got it. And you'll see here it's actually server host, so it just logs me in right now, and I'm in sort of a PowerShell experience here. And so I can just list and see sort of where I am and kind of experience this just like I would on a normal Windows box. But the difference is this is actually, of course, has Docker available. And so very, very similar experience. I can even say Docker and see sort of all the commands that are available. Very similar experience. Docker run. Again, the interactive mode. I'll actually give it a name instead of letting them pick my name. And pick the one image that I've got, the Windows Server core image, and with CMD as the option. And so in a very similar way to what I just showed you with Bash on Linux, I'm going to be able to do the exact same thing here on Windows with CMD. And so in the same sort of command, the same experience, if you're familiar with the Docker APIs and capabilities, you can move over to Windows and you can get nearly the exact same things accomplished with, again, the same sort of experience and speed to deploy and launch. And so you can see, again, within seconds on the Windows machine, I've now got CMD up, and this is, again, running as part of a container that's running on this virtual machine. And so again, I can go in and I can go and make a directory. Corey rules again. Okay, make this directory. And so you can see now I've got Corey rules again here on the C location. And from here, let me actually, again, this is happening as part of the virtualized container. Let me exit the container, and this is going to take me back into the virtual machine, the OS experience for the host. And so again, I'm back now, and you can see I'm in the user's Corey directory. And let me go back to here, and you can see actually there it's not there. The directory that I had created is not there because again, it was a virtualized directory. And so from this, let me actually go ahead and do similar sort of commands. Do I have any containers running? No, none running right now. But how many are actually asleep? Okay, well, here's a few asleep. So I've got that Windows Server one that I just created. And so you can see here, there it is, Docker demo, created. Same sort of experience. Let me actually go in and let me actually commit it. And so I can now create a new image from this. And in, again, a similar, very, very fast time, I'm able to get that up and get that created. And so from here, I'll be able to launch a new Docker container using this image that I've created, which again should then show that same directory that was created the first time. And there you can see it finished. And now I have my new container image ready to go. Let's actually take a look and see the images I have. And so again, you can see I've got a few images created, and there's the new container image that I just created as part of this process. And so I can again go in and actually create a container from it. Again, from a interactive mode, let me give it a name here. Docker demo 2, pick this new container image, and again, start up CMD. And so from here, this is expected to start this new image that I just created from that previous container. And again, in moments, I have this container up and running and ready for me to use. And there you can see up and running. And so let me go back to that, to the C directory, and there we go. Corey rules again. and sure enough, based on this demo, true statement. So there you see the directory available in the C drive. And so the image that I made, I can redeploy, I can make hundreds of these, and away I go. And so the only last step worth showing here is, again, a very similar experience that I showed you on Linux, to be able to open up an endpoint and be able to run a web-based application in a similar way. And so let me actually run through that. And so what I've done here is I've already opened up port 80 on the network security groups so that this should be able to be accessible from the internet. And so I'm picking port, and I'm going to go 80 to 80, and I'm going to spin up an Nginx solution and actually go in. And this is an Nginx running on Windows that now I will configure. And so when I spin this up, this is going to create a CMD for me. This is going to create a command line that then I can go in and actually kick this up. I've already started and created this container image for me to be able to easily start an Nginx prompt. So let me do this and actually go Nginx. It's already installed on this machine because I've already pre-created this. And then I can do start Nginx. And this will create that web service. And so let's go over here, and this is a serve container Windows. And so from here, I can actually, let's open this up. Here's the public IP address. So I actually go to it. And there you have. Welcome to NGINX. This is running on a Windows machine. This is running on a Windows container, in a Windows Server container, on a Windows machine on Azure. And so from there, you really get into questions of how are people going to use them and how do you want to use them? And so the flow for creating containers, as I showed you, is amazingly simple. You can add things, you can install things, you can build things. As a developer, you build and test them, and you prepare them in exactly the way you want them. From there, you can push them to a repository, you can keep them on the local machines, you can push them up into Docker Hub, and anyone can use them, including all of your coworkers and friends, your family, your mother, whatever it may be. They can all use that container that you've built. Then once you're satisfied with it, the operations team, whether it's you yourself or whether it's some friend down the hall or it's some system administrator down the street, they can then take those containers and automate deployment and management of those containers as part of a broader application, enabling very easy deployment and launch of these solutions across any environment that you may have. And as I showed you in the two demos, the controls and the commands are the same for both. Very easy to get started on Azure using these machines in both and launch them in a really simple way to make this type of application flow very, very simple. And then from there, perhaps there's updates, there's improvements, there's fixes. Operations can then work back with the developers to provide the metrics, the insights of what's happening with those containers. Updates can happen, new fixes can go in place, and away we go with the process all over again to update those containers, push them back out, and around we go in moments as those containers get deployed in lickety-layup speeds. This creates a new DevOps experience like we haven't seen before. It allows fast iteration, rapid deployment, and very simple integration between the developer and the system administrator, enabling this amazing empowerment for developers and simple control for the system administrator to be able to launch the developer solution. And so the very last demo that I'll show you is a very special solution as part of Azure. And so one of the things that we've tried to make very easy in Azure is getting started in a really simple way. And so what we've done in Azure is instead of forcing you to go through all the process that I just walked through, learn how to set up the ports and configure things, we wanted to get a few samples going that pull directly from Docker Hub using the extension that we've written in Azure, install on the box, and prepare your machine immediately and very easy. And so you can go down to the portal experience and click straight on container apps. And let's actually click open the marketplace. And so here you'll find a bunch of solutions that we've pre-created that pull from Docker Hub and enable you to spin these up in the form of a container for you to go play with, learn from, and even build applications on. And so here you can see we've got Redis, MySQL, NGINX, Jenkins, Memcached, many options. Even few that use Compose, which is a Docker capability to bring multiple containers together in a single guest, in a single machine, with something like WordPress and MySQL. It will connect them and deploy them together on a single box. And so with this capability and the ease of the portal experience, you can actually go through, configure it, and have it all set up for you to go once you log in. And here you can see it even takes special parameters that you may need as part of this specific container solution. So here, my MySQL root password, a specialized command prompt that you can pull from this and make it install very easily on your container. And so instead of actually spinning one of these up now, let me actually go back. I happen to have spun one up earlier today. And so I already have one that had NGINX available. And so here, this is completely spun up, and this was, I did not even go on the box. It's got Docker running on it. And so here I can click to copy, and I can go and connect to it. And here, actually, this is an NGINX one that's actually locked down access by default, so it's actually blocking me here. But you can see that this does have NGINX set up. And if I were to SSH into this machine, I could see Docker running with that container set up already for me. And so if you're wondering how to get started, even easier than pulling Docker down and installing and trying one of these containers, you can deploy one of these. We'll pull down Docker, we'll install it, we'll then pull down the container that's available, and we will configure it appropriately. So you can go in and just sort of learn in a very easy way using Azure, very quick and very, very simple. And so the last few points that I wanted to touch upon when it comes to Docker and Azure and containers is really first on the Windows Server container side. And this is future direction. We've talked about this extensively outside about the future of the Hyper-V container. And this is taking the Windows Server container, but offering an additional level of isolation, where they actually have isolated the guest OS, the Windows guest OS, across these different containers. And so the nice thing is it's still consistent. It's the same API. It's the same Docker experience. It's the same images that you created. The image that I created on this box that had the Cori directory in it, this will be deployable on a Hyper-V container or a Windows Server container, and it'll be a decision at deploy time which way you want to go. That compatibility is very powerful. It enables, again, a deploy time decision over what to do. The additional power that Hyper-V containers bring is an added level of isolation. Because the Windows guest OS that's then deployed as part of this is isolated and dedicated, it creates an additional level of isolation where each one actually gets their own guest OS, and so issues with that guest OS cannot impact the other containers on the box. And of course, creates a very highly trusted environment using the proven technologies of Hyper-V. So let me spend just a minute on what's next. First of all, from an orchestration perspective, as you see more and more of these containers become available, and I showed you just a few being spun up, hundreds, thousands, even into the millions across a set of virtual machines, suddenly you start worrying about how you're going to orchestrate and manage them. And there are many different options, many different solutions that are out there. The ones that we've really focused on is working very closely across both Docker and across Mesosphere to offer solutions that are using Apache Mesos, Marathon, and Swarm with Compose, and being able to offer orchestration solutions that tie these components together in a really nice way. And that is the very recently announced Azure Container Service. This solution is a streamlined way of provisioning Apache Mesos clusters that will allow the layering of support of Swarm, Marathon, or Kronos on top of it, with, of course, the tried and tested and very popular Docker tooling and API support that will be able to support both in public and private clouds. And so this will be available as an Azure service. And if you want to see more details on this, you can find Ross's video that spends most of the time talking about this new service and the capabilities that we will offer with it. And finally, the last aspect of where containers are going is the new programming models and concepts called microservices. And with microservices, you can take what used to be a monolithic, single, huge application, and now you can split it up into composable parts. This enables easy development, easy scale out, and easy update. You suddenly can update specific portions of your app. You can scale out specific portions of your app. No longer are you a full monolithic thing. You can now split them up and deploy in moments on Linux or Windows machines and be able to track them as these composable parts. Very exciting. And as we've already talked about, we do have a native solution that we've built as part of the Azure platform that is called Service Fabric that will make deployment of these microservices amazingly easy, simple, and streamlined on the platform. And making this a very easy update of consistent state migration and replication across these nodes, and very easy scale out across them, really, really powerful. And so this is a future direction for where containers and microservices and computing in the cloud will be going. And we're really excited to be a part of this and to be delivering a major portion in the future of this platform. With that, I want to thank you for your time, for sitting here and listening to me talk and show you a few things on both my Mac and my Windows machine. Hopefully you enjoyed the time, and thank you again, and have a good afternoon or evening or morning.